Good day everyone. Jesre Earl Dales of BSE 3C here to report my activity number 8 in ECE 37. What is a CPU? Created by Pamela Fox. A CPU being the brain of the computer, having all the circuitry for processing, input, storage, data, and output, is responsible for the computation and processing of all the data given to the computer. Next, Moore's Law. An observation that given tremendous innovation in the electronics industry by having double the ratio of resistor in space provided, being capable of making cheaper electronics and makes lives easier. The history of CPU started in the 1940s, where they are still unreliable and prone to errors. Also different in size, the way it is made, and the functionality compared to our modern technology despite being the cutting edge technology of that time. In the late 1940s, it had started to be upgraded into more faster and smaller circuitry for electronics and also to be more reliable and easy to use. The monolithic integrated circuit was founded by Robert Noyce in the year 1959, symbolizing the greater improvements in the field of electronics. And in 1968, Intel was founded, and the first microprocessor it created was released in 1971. And in 1972, they had made great contribution in making CPU architecture designs, and in 1978, they pioneered the design we use for the microprocessor we use today. In regards to computer computing, binary system is much more suitable than in machine language or decimal system due to the simplicity and easier for doing complicated tasks. And by stacking layers, it makes more computation and complex processes easier to be used as information. Instruction Set Architecture or ISA makes the definition on how the central processing unit is controlled. By being the abstract model of the computer, it acts as an interface between hardware and the software. Being implementation independent, the ISA makes the products of different microarchitectural designs become homogeneous in some sort, making it related to each other even in diverse designs that they are made into and only varying in the terms of the work they are made to do into as implemented. And as the time passes, it continues to be more modern and being fitted to the era, being upgraded into more functional and be more reliable. CPU pipeline. The key building blocks in a CPU are a series of execution performed inside the CPU, whether it is computations, conversions, translations, starting from data fetching, decoding, into executing, and to the last data write back. Being similar to an assembly, and being more complex as time passes, and by adding more parts in each stage or adding more stages, the fewer it is done and become more easier to process data in a short amount of time and also lesser cost. Speculative execution is where the data is proven true before going to the next stage. An intensive checking of data process that determines the error of the execution and to be able for the CPU for a great performance, and by using the speculative execution predicts branches with almost perfect accuracy, similarly to clairvoyance, making the right path to take for the data. By going through numerous extensive processes, from predict and fetch, where data is accurately selected, and where to get the data next, into decoding, where relevant information are used to decode instruction in an efficient way. Next, into the superscalar execution, where a single instruction is addressed at a time, making it to determine the microprocessor width, and into the out of order, where the unnecessary instructions are removed to prevent unneeded waiting times, and into the backend. By using this in either or both in parallel and out of order, you can efficiently use the CPU with the correct answers in the end of the stream, and even when dealing huge amount of instructions, we are sure that we are correct in the answers. End of the slideshow, guys. That is the end of my report. Thank you for listening and have a good day, everyone.